Okay, good morning. So today we're working on lesson 11.8, which is adding and subtracting radicals. Our objective is to simplify sums and difference of radicals, and there's two steps we're going to follow when we do that. The first one says express each radical in simplest form, meaning that your radicand does not have any perfect square factors. Second, you're going to add or subtract like radicals, just like we added and subtracted like terms. It says unlike radicals cannot be combined. So unless they are like, meaning the same root, which they will be because we're only doing square roots, but they also have to be the same radicand. Okay, so let's do some practicing. It says simplify. Assume all variables represent positive real numbers. Again, that means you don't have to worry about absolute value symbols if you have any variables. Number one, 4 times the square root of 7 plus 5 times, that plus is way too close, plus 5 times the square root of 7. These are like radicals because they have the same radicand. So on the outside, you take care of your 4 plus 5 first, which is 9, and you keep your square root of 7. You don't add that and make that the square root of 14. Okay? The only way we can add these was because, so what we're adding is what's in front, and we're keeping the square root of 7. Just like if this was 4x plus 5x, we'd make that 9x. All right, number 2, 3 times the square root of 6 minus 2 times the square root of 13 plus 5 times the square root of 6. Okay, in this case, I'm going to combine my like radicals first. So I see that 3 square root of 6 and 5 square root of 6 have like radicals. So that's 8 square root of 6 minus 2 times the square root of 13. Square root of 6 and square root of 13 are not like radicals, so we are done. We leave it just like that. Number 3, 7 times the square root of 3 minus 4 times the square root of, ooh, that's a terrible 4, minus 4 times the square root of 6 plus 2 times the square root of 48 minus 6 times the square root of 54. All right, so let's see what we got here. I have 7 square root of 3. I have 4 square root of 6. Neither of those have any perfect square factors. What about 48? 48 definitely has a perfect square factor of 16. So I can rewrite this as 2 times the square root of 16 times 3. Minus 6 times the square root of 54 has a square root factor of 9 times 6, a perfect square factor. So let's go ahead and clean these up. The square root of 16 is 4. That's going to come out front. The square root of 3 stays inside. Minus 6 times the square root of 9 is 3. That's going to come out front, and the 6 is going to stay inside. So let's rewrite this whole thing. I have 7 times the square root of 3 minus 4 times the square root of 6 plus 2 times 4 is 8 square root of 3 minus 6 times 3 is 18 square root of 6. If it helps, rewrite your like radicals together. 7 square root of 3 plus 8 square root of 3 minus 4 square root of 6 minus 18 square root of 6. Combine your like radicals. You get 15 square root of 3 minus 22 square root of 6. And that's all you can do. Okay, let's do one more together. And then I'm going to let you try 3 of those on, well, you'll try 3 on your own and just check them with the answers that I give you. Let's see. 4 times the square root of 112 plus 5 times the square root of 56 minus 9 times the square root of 126. All right, so 112 definitely has a perfect square factor. I see it ends in 12, so I know something times 4 will give me that. But if I think further into my square root factors, I'm going to try 16. And I know that 16 times 7 gives me 112, and 16 is a perfect square factor. So I'm going to rewrite this as 4 times the square root of 16 times 7. Plus 5 times 56. 56 has a square root factor of 4. 4 times 14. Minus 9 times 126. 126 has a perfect square factor of 9 times 14. All right, so let's clean this up. The square root of 16 is 4, so we get 4 times 4 times the square root of 7 plus 5 times the square root of 4 is 2 times the square root of 14 minus 9 times the square root of 9 is 3 times the square root of 14. So this gives us 16 square root of 7 plus 10 square root of 14 minus 27 square root of 14. My like radicals are 10 square root of 14 minus 27 square root of 14. So I end up with 16 times the square root of 7 minus 17 square root of 14. Okay. I want you to try these. I'm going to put the answers with it, but you need to solve, and of course always reach out to me if you don't get the correct answer. Negative 13 times the square root of 17 minus 7 times the square root of 17. You should get negative 20 square root of 17. The second one, 5 square root of 3 plus 2 square root of 75. You should get, ooh, that's terrible. 15 times the square root of 3. And the third one, negative 4 square root of 2 plus 6 square root of 72 minus 8 times the square root of 32. You should get 0. Okay, so try those. Okay, we're going to do another section together of a few. All right, we're still adding and subtracting. This says the square root of 15 minus the square root of 3/5. Okay, so we got a little bit of work to do on these. So let's go over these and figure out the best route. So I have a fraction, and I also just have the square root of 15. So I'm just going to write a 1 under that so we know that that can be written as a fraction. Then in this next step, I'm going to go ahead and I'm going to rewrite the radical individually to the numerator and denominator of the second one. So it's the square root of 3 just divided by the square root of 5. Okay, this is not simplified because it has a radical in the denominator. To undo that radical in the denominator, I'm going to multiply it by that radical. So now I have the square root of 15 over 1 minus 3 times 5. We can multiply that as the square root of 15 over the square root of 25. We know that the square root of 25 is a perfect square. So this becomes the square root of 15 over 5. Now, in order to subtract fractions, we have to have a common denominator. That means we're multiplying this first radical expression by 5. So we get 5 square root of 15 over 5 minus the square root of 15 over 5. We now have like denominators, so we will subtract what's in the numerator, so we get 4 square root of 15 over 5. If you're wondering why we got 4 square root of 15, because it's an understood 1 right here in front of that. And 1, when you take 1 from 5, you have 4. Okay, that's the first one. The second one, the square root of 2/7 minus the square root of 7/2. You have to be careful with these because when we are multiplying and dividing, you could put them under one radical. You can't really do that with what we're doing now because we're adding and subtracting. Okay, so first we're going to break up our radicals to the square root of 2 divided by the square root of 7 minus the square root of 7 divided by the square root of 2. Okay, none of them have perfect squares in their radicals, so I have to take care of my denominators. This first denominator, I'm going to multiply top and bottom by the square root of 7. The second radical, I'm going to multiply it by the square root of 2 over 2. I can multiply these. 7 times 2, square root of 14. 7 square root of 7 times the square root of 7 is square root of 49. Okay? And then we have the square root of 14 over the square root of 4. All right, perfect squares in our denominator. Square root of 49 is 7. Perfect squares in our other denominator, and it's the square root of 4 is 2. Now, we cannot subtract these. We do not have a common denominator. To get a common denominator of 7 and 2, the smallest one would definitely be 14. So, I'm going to multiply the first one by 2 over 2, and I'm going to multiply the second one by 7 over 7. So I get 2 square root of 14 over 14 minus 7 times the square root of 14 over 14. Remember that you cannot multiply a number with a radical. They both have to be square roots to multiply them. So then I have 2 minus 5, 2 minus 7 is negative 5, square root of 14 over 14. And that's all I can do because I cannot simplify something that's a radical with something that is not. Number 3, let's do another one. The square root of 2/3 plus the square root of 5/6. I'm going to separate them so I get the square root of 2 over the square root of 3 plus the square root of 5 over the square root of 6. Nothing I have there has perfect square factors, so I'll go ahead and multiply this first radical by square root of 3 over square root of 3, and the second by the square root of 6 over the square root of 6. I can multiply these. 3 times 2, that's the square root of 6. 3 times 3 is the square root of 9. If you can go ahead and simplify it, do it in that step and just make it 3. I'm just doing it out for all of you. 5 times 6, that's the square root of 30. 6 times 6, square root of 36. This is a perfect square. I now have the square root of 6 over 3. This is a perfect square. I now have the square root of 30 over 6. I need a common denominator of 3 and 6. It is 6, so I will multiply this by 2. So I get 2 square root of 6 over 6 plus the square root of 30 over 6. All right. I cannot combine the square root of 6 and 30. They are not like terms, so they just become one numerator, all over 6. And if you think about 30, there's no perfect square factors, so there's no way to simplify the square root of 30 anymore either. All right. Let's go on to this last one. Number 4. 5 times the square root of 16/3 minus the square root of 9/2. All right, so we know that 16 is a perfect square. So I can rewrite this as 5 times the square root of 16 is 4 over the square root of 3. And when I write this 5, I might as well just make it a fraction. So you know that that's what that means. Minus the square root of 9, that's 3 over the square root of 2. Okay, so this becomes 20 square root of 3 minus 3 over the square root of 2. I don't have any perfect squares in either of my radicals, so I'm going to multiply the top and bottom by the square root of 3 over 3 on this side and the square root of 2 over the square root of 2 on this side. I get 20 square root of 3 over square root of 9. Minus 3 square root of 2 over the square root of 4. From there, I get 20 square root of 3 over 3 minus 3 square root of 2 over 2. I need a common denominator. It's going to be 6 because I have 3 and 2. That side will multiply by 2, this side by 3. I get 40 square root of 6 over 6 minus 9 square root of 2 over 6. Okay, same denominator, I'm subtracting, so if I can, I combine like terms, but there are no like terms. So this just comes over as the numerator, and it's all over 6. All right, so that is adding and subtracting. I have homework set up for you, so just feel free if you're struggling on any of this to make sure you reach out to me with messaging, and we can set up a Teams meeting. All right, y'all have a good day.